at least with some basic introductions. So hi everyone, my name is Anna Mostovetsky. I work for the Whatcom County Health and Community Services, along with Josh Leinbach. Josh, if you want to just wave and say hi to everyone.
Hello, hi to everyone.
Um, so yeah, most of you who are here are probably familiar with this project. This is a journey that we embarked on a couple of years ago. As many of you know, Weiser Lake has had chronic harmful algae bloom issues for many years. And in 2022, we applied for a grant with the Department of Ecology to try to tackle this issue and collect some data, some preliminary information about this lake to hopefully help us figure out what some of the drivers are of these toxic blooms, and also how to resolve this issue, or at least try to. So we spent last year collecting some baseline data, and then we were awarded an additional grant, and we were lucky enough to be able to hire Mark Rosenkrantz with Aquatic Insight and his team of colleagues who have been working really hard analyzing all the data that we collected and compiling a lake management plan. And so Mark will talk all about that. So before I hand the mic over to him, I just wanted to go over some basic Zoom etiquette. It would be really helpful for the speakers if you folks could mute yourselves and also turn off your videos if you're not presenting, just to minimize any distractions. We will have time for questions. Mark broke up the presentation into different sections, and so there will be section breaks, and that'll be an opportunity for you to ask questions. Feel free at any point to type questions into the chat as well, and then we can address those during the section breaks. And during those breaks, you can use the icons down below to raise a hand. If you can see the little react icon with a heart on the bottom, that's what you would use to ask a question. So unless I'm missing anything, I think I'm going to hand it over to Mark, and we'll go from there.
Thank you, Anna, and welcome everyone. Thank you for taking some time out this evening to let us share with you the information that we're going to talk about on the lake. Let me make sure that we can see this screen. Everybody see my screen? Is that okay, Anna? Is that showing? Okay, excellent. All right, so going to have a little bit, our agenda for this evening is we'll start out with some introductions, and then we're going to, we've broken it up.
Recording in progress.
We've broken it up into 4 sections, and like Anna said, after each section, there'll be an opportunity for you folks to weigh in with some questions or comments on what you've seen. Now, I want to also say that this is not part of the reason that we're here is to get ideas from you and get we're not as familiar with this lake as you folks are, who have been living in this region for a long time. I've been to the lake, I've seen it, but I've certainly not interacted with it as much as you. So we're really curious to get some feedback from you folks about what you think about our presentation, and if you think we're going on the right track, or if we need to adjust it a bit. So, feel free to offer during the Q&A discussion sections. Just feel free to freely offer your opinions. So the section 1, that's going to be kind of a long one. So I don't want to get too much in the details, but I do want to also present the information that Anna and Josh and the county spent a lot of time and a lot of effort gathering to go into this, to feed into this plan. So I want to do that justice and talk about it. And then that kind of provides you with information about how we got to our conclusions at the end. And then section 2, that's talk about the water and the nutrient budget. Where does the water come from? Where do the nutrients come from? And then what does that mean for the lake in general? Section 3 will go into our management options. And then section 4, funding opportunities. So having said that, I am Mark Rosenkrantz with Aquatic Insight. We're a consulting firm down in Portland, Oregon. Yeah, it seems like a long way from Weiser Lake, but fortunately, Anna and Josh did the data collection, and we're doing the analysis. I've been doing lake work for 30 years and doing these doing these kind of projects frequently. So, and then Elizabeth Seebacher, if you want to introduce yourself.
Sure. Elizabeth Seebacher, and I'm working with Mark and with Rob now as an independent consultant. I was with the Department of Ecology for almost 13 years, 12 and a half years or so, as working on lakes, running the cyanobacteria programs or the toxicology program and the aquatic invasive plant program, as well as the cyanotoxin program that Ecology has, which many of you probably know about. I also am a research scientist at the University of Washington working on stormwater. And I still am doing that as well as doing the consulting at this time.
Thank you, Elizabeth. And Rob?
Sure. I'm Rob Anier. I'm an environmental engineer focusing on water resources. I've been working on lake projects similar to this for the last 20 plus years. I've known Mark since graduate school. He and I went to the same university for graduate school, and we both have a love of working on lakes. So happy to be here.
Thanks. And yeah, Rob and Elizabeth were very instrumental in making this a successful, hopefully a successful management plan for you folks. So section 1, we're going to start with the background and the monitoring results. So as you know, Weiser Lake is bisected by guide meridian. And as such, the data collection treated it as 2 separate water bodies. The bridge between the 2 basins is pretty narrow, so they kind of act like 2 separate water bodies, particularly in the summer when there's not a whole lot of water moving through the system. So, and the eastern basin, which we call WL2 in on the data, is a little bit deeper. And so what the data collection there was, we treated that as potentially a stratified water body. So, and we'll talk about stratification in a little bit. So treated that a little bit differently than Weiser Lake, or I'm sorry, than the West Basin, which is a bit shallower and acts like a much shallower water basin. So just to kind of give you an idea of where the data were collected on the lake and what these 2 basins look like. And so, and also wanted to provide a little bit of a background on sources of phosphorus to lakes. So we've got 2 primary sources of phosphorus. Our internal phosphorus sources, which those come to the lake from below the water level, like groundwater infiltration, you can see, or sediment reflux, or in other words, phosphorus that's released out of the sediment. Then the external sources, phosphorus or nutrients in general, those come from outside the water body, like from the watershed. So precipitation, discharge from stormwater, direct runoff from the landscape, Now, there's no real stormwater system in the Weiser Lake Basin, so the discharge from that would be just kind of runoff that's maybe the road runoff would be about the only thing that's equivalent to that. So that kind of gives you a little bit of a background on the two sources of phosphorus that we're dealing with in the lake. And so the sources of external loading, so these, this image shows the two watersheds that we're dealing with on the lake. The green outline, that's the water that flows into Cougar Creek upstream of the lake. And so that would enter the East Basin at the very east end. And then the yellow outline is what's draining directly from the watershed into the lake. And so the things that affect nutrients in these broader basins are septic tanks. There's several hundred septic tanks in the watershed. Agricultural production, you can see quite a bit of that in the green outlined area. Waterfowl, which interestingly, that turned out to be a pretty significant component of nutrients during the migration period. Stormwater runoff, that's something that drains directly into the lake from the immediate watershed or from the road. Lawn fertilizer and groundwater. Now, when I talk about groundwater, that's kind of an interesting, I wouldn't say unique, but it's a little bit interesting because it comes into the lake from under the surface. So it could be considered an internal phosphorus source, but the nutrients that are derived that end up into groundwater, those come from the watershed, from external sources. So in some systems, it's kind of difficult to tease apart how much of the nutrients that are coming into the water through internal sources, are they from groundwater or are they from processes that happen inside the lake that are contributing nutrients? There's ways that we can kind of estimate that, but that's why we put the asterisk on there, because it's not really external loading or it's not really internal loading. It's a little of each. And so we talked a little bit about external loading, and then we can talk a little about the processes that lead to internal loading. So internal loading includes groundwater, but a large component is chemical activity in the sediment. So some of you may be familiar with temperature stratification in a lake, but I'll go through it briefly here for those that aren't familiar with the concept. In deeper lakes, which are more susceptible to thermal stratification, this time of the year, a lake is the same temperature from top to bottom. And the lines that you see on the, I don't know if you can see my cursor dancing around or if that's just me, but the lines that you see on here, the yellow one is representing dissolved oxygen, and the red one is representing temperature. So this time of the year, those lines are straight, they're vertical, straight up and down, because the water at the top is the same temperature as the water at the bottom. But what happens during the summer is the water at the top warms up through sunlight. The wind mixes that to a certain depth, and that is your epilimnion. So the part of the lake near the surface where the temperature of the water is the same is our epilimnion, and then it starts to decrease as you start to get out of the influence of wind mixing, the water temperature decreases clear to the bottom, as you can see on the red line. What happens then, the effect of that is the layers of water, the epilimnion at the top, the hypolimnion at the bottom, they don't mix. And so you have a condition down at the bottom where you have next to no oxygen or zero oxygen because there's not enough light for photosynthesis to generate oxygen, and the wind isn't mixing the oxygenated water from the top down to the bottom. Now, this example that I have here is a 20-foot deep lake, and it's about twice as deep as Weiser Lake. So that doesn't necessarily hold true for Weiser Lake, but I just wanted to kind of give you a little bit of a introduction to this stratification idea as we go through the rest of the data, because it's going to be kind of important to have a little bit of an idea of what's going on. And so as we move on to our phosphorus data here, the nutrient sampling, it shows really high phosphorus. So this is on our y-axis here, phosphorus concentration in micrograms per liter. Now, for
actually, I'm in a meeting, but anyways,
for typical sorry, for a typical lake, we like to keep our phosphorus concentration under 20 micrograms a liter, because that reduces excessive algae blooms and cyanobacteria blooms and creates a more healthy lake. And as you can see here, we have a phosphorus concentration over 300 micrograms a liter in our west basin and over 200 micrograms a liter in the east basin. So super, super high phosphorus. Now, it's also high in the winter in the two and the shoulder areas of this graph, but it really increases pretty dramatically in the summer, and that is an indication of internal phosphorus releases, because there's not very much water coming in from the watershed at that time, and so it's not really being fed from the creek, and so all that additional phosphorus is coming from the sediment from within the lake. And and you can, if you look at the bottom left there, you can compare it to what's coming in the creek, and it's the creek phosphorus is still pretty high, but nothing near what it is in Weiser Lake, in the lake proper. So it's not the creek that's providing all of this phosphorus. It's something else going on. And so, but on the flip side, though, if we look at our nitrogen data, the nitrogen concentration during the summer is relatively stable, but it really picks up in the winter. So that tells us that the nitrogen that's coming into the lake is primarily coming in during the winter, during runoff. So the source of the phosphorus is internal loading by chemistry in the sediment. The nitrogen coming into the lake is from runoff from the watershed, coming in through Cougar Creek. And so we talked about this a little bit, but the external loading, why do we have such high high nitrogen coming into the lake in the winter? And right around the lake, we've got 405 properties, all on septic. Well, not all of them on septic. Some of them are agriculture only properties, but the majority of them are on septic. And then waterfowl that move between the lake and and the fields. Like a lot of them, particularly the geese, they'll graze on the fields around the watershed and then fly into the lake and make deposits into the lake and really just kind of transferring nutrients from the watershed directly into the lake through their fecal matter. And then the broader watershed, the Cougar Creek watershed, again, now the 330 tax lots here, a lot of those are agriculture without homes on them, but there's still a fair number of septic tanks in this watershed. But there's a lot of agriculture, and do they, is that property, is it irrigated? Are they applying manure to these properties? And again, more of an attraction for waterfowl to move between the lake and these agriculture areas. So that's kind of our the extent of our external loading there. And then waterfowl, I mentioned that earlier, and you can see during the migration season, we've got in blue here, we have our ducks, and then orange are geese and swans, and then the gray are various other birds. But there's a huge amount of waterfowl that move through this area in the winter. And again, as we see later, we built that into our nutrient model to see what kind of a contribution they would have to the lake. And it could be significant with this many birds. Now, what we don't know is this waterfowl census, it was just counting birds. It didn't specify whether those birds were on the lake or whether they were in the watershed or grazing somewhere on the fields. So depending on the species, some of the species, they spend much of their time on the water. Others spend more of their time grazing in the watershed. We didn't know that mix, so it wasn't a simple process of extracting exactly how much of a direct impact they have on the lake, but just made assumptions based on literature on what the contribution to the lake would be. And so we saw a version of this earlier. And so this is a representation of what stratification is like in Weiser Lake, or the lack of stratification. So in deeper lakes, remember, the temperature starts to decline once the influence from the wind ceases. So on a deeper lake, that's say about 15, no, I'd say it's about 10 or 12 feet or so, typically, depending, of course, on the speed of the wind. And so that means that if you have enough wind, if the wind energy is high enough here for Weiser Lake, then the lake is going to be constantly mixed from the top to the bottom. It's not going to have a chance to stratify. Now, the lines that you see on the chart here are similar as before. So the dissolved oxygen in yellow and the temperature in red. And you can see the temperature, the red line, seems to be fairly vertical. But we are starting to see some oxygen depletion in the yellow line. This was data from, I think, August 8th, so around the hottest time of the year. So a time when the stratification is most likely to be occurring. And so when the sonde was when the device was used to collect this data, it was held off of the bottom by about half of a meter, which is typical when you're doing studies like this, because you don't want to stir up the sediment. But the dissolved oxygen might decline even more if the sonde were lowered clear to the bottom. So there might be some stratification or some anoxic conditions right near the sediment water interface. So we'll talk a little bit about that later and what could be causing that. See, just checking my notes, making sure I've covered everything on that. Yeah. So, and we'll talk about this more in particular on later slides. And so, looking at it a little bit more, these are not looking at individual profiles, but the trend for the temperature and the oxygen trend throughout the course of the year. And you can see in the in the West Basin, WL1, the temperature near the surface on all of these charts, the data near the surface is the orange line and the data near the bottom is the blue line. And if they're staying together, that means the water body is pretty well mixed. And so on both of these, the East Basin and the West Basin, it shows that the temperature is pretty steadily, they're pretty consistent. Both of them they're right on top of each other, meaning the temperature, the top and the bottom are the same. But if you look at the bottom charts, you start to see some oxygen near the bottom starting to move away from, starting to decline from the oxygen concentration near the surface. So something's going on. If we're fully mixed, like it shows up on top, then we shouldn't have oxygen depletion at the bottom, because the oxygenated water near the top should be mixing thoroughly with the oxygen at the bottom. So something's going on here. So we thought that we needed to kind of explore that a little bit more. And so what is this, all of this phosphorus in the lake, what is it causing? Our phytoplankton concentration in both in the West Basin here, what we're looking at here in WL1, the cyanobacteria was dominant in July and October. Particularly in October, there was quite a bit of cyanobacteria in the lake. And almost all of it was Anabaena flossaque, which and on both July 10 and October 10, that was the dominant cyanobacteria species. So the top chart here, the top graph shows the population of the phytoplankton, all phytoplankton species. And then the bottom one shows that broken up into just the cyanobacteria species on these particular days. And so the significance of the Anabaena flossaque is, excuse me, it is a nitrogen fixing species. It can produce toxins. It doesn't, cyanobacteria don't always produce toxins, but they have the ability to produce toxins. And it can adjust its buoyancy, and so it can move through the water column and seek out areas where it's optimal growth areas. So it can move up in the water column if it needs to be more exposed to sunlight, or it can move down in the water column if it needs to access nutrients. So Many cyanobacteria have these adaptations to be able to outcompete other algal species. And then in the East Basin, the same thing. It was dominated by Anabaena flos-aquae, but the concentration of phytoplankton and cyanobacteria was quite a bit less than what it was in the East Basin. I'm sorry, than it was in the West Basin. And there may be a reason for that. Is that might be on the West Basin, the wind might be concentrating cyanobacteria in our algal population up against the causeway for the road. So concentrating it on the eastern edge of the West Basin. Whereas in the East Basin, the wind would be shifting it towards the east end of the East Basin, which is opposite end of where it was sampled. So there may be a difference in, depending on where you're sampling, and this is the case frequently, depending on where you're sampling, you're going to get a different concentration of phytoplankton, depending on the local conditions. But regardless, the Anabaena is still the dominant cyanobacteria species in the lake at that time. And then chlorophyll, the chlorophyll concentration was confirming that we had a high algal activity in July and in October on both the West and the East Basins. And then the other really informative and really easy data to collect is a Secchi reading, and that just essentially that measures transparency. So you use a disc, a round disc with black and white quadrants on it, and you lower that in until you can't see it anymore, and that tells you what the water transparency is. And as you can see through much of the summer, it was under, well, it was right around a little bit more than 1/2 meter. So that's, maybe 1.5 feet or so, a little more than 1.5 feet of transparency. So not very, water certainly wasn't very clear in the lake. Now, there were periods when the algal population was much lower, and that's where you start to see these deeper, these better clarity numbers here. And so also note when the scale, the y-axis is reversed, because when we do Secchi, we like to show how far down in the water column these charts show. And so we reverse the axis, and then the brown dashes here, that represents the bottom. And you can see there were a couple of times when they lowered the Secchi disc in, they could see all the way to the bottom. So that's during the spring, before the algal activity really started to take off. So wind mixing, I want to talk a little bit about, a little more about internal loading and why, if it looked like the lake was fully mixed, why are we saying that there's a lot of internal loading from anoxic sediment, which is typically what causes internal loading? And looked at the, and this is where we kind of need some help from you folks to see if this is accurate representation of the weather around the lake. We grabbed some wind data from the airport down in Bellingham. And we noticed that during the day, the winds get pretty breezy through here with gusts, 20 miles an hour, 30 miles an hour. But at night, it calms down. So we wanted to take a look at this in a little more detail. And so we looked at a period between August 11th and August 21, and that's also about the same time where our phosphorus concentration really started to increase. And so, all right, so we were wondering if during the day the lake is mixed, but at night, could it become calm enough that it does start to stratify and we start to see oxygen depletion at night? And there might be something to that, because if we look at some of these days down here, we've got like 6 hours or so of calm weather at night. Many times it's calm. We have calm weather for several hours at night, and that's not unusual in this region. It usually does. The wind does settle down at night, but sometimes for fairly long periods of time. And so, is that allowing the lake to become thermally stratified, and also with all this algal activity in the lake, during the day it's photosynthesizing, the plants and the animals, or I'm sorry, animals don't photosynthesize. The plants and the algae are photosynthesizing and creating oxygen, but at night they're respiring and they're consuming oxygen. And the dead algae and the dead plants at the lake bottom, those are also consuming oxygen. So is there enough of that going on at night where we start to see a depletion in oxygen, and then that releases phosphorus from the sediment, and then during the day the wind picks up and it mixes that phosphorus up into the water column and creates these really high numbers? So that's one thing that we're looking at, or we looked at, to try to see if that's is that what's going on? Is that the reason? So and moving into our sediment data, this is kind of an important component of that. Is they pulled sediment samples and they did sediment cores in each one of those basins, and they sliced them up into 5 centimeter sections and had those analyzed for iron-bound phosphorus, aluminum-bound phosphorus, biogenic, calcium, and organic phosphorus. Now, what they considered bioavailable phosphorus is the iron-bound and the organic. And they consider iron-bound phosphorus available because under anoxic conditions, when there's no oxygen in the sediment, there's a chemical reaction where the phosphorus that is typically bound to iron, that gets released up into the water column. And so if you have a lot of iron-bound phosphorus at night, that is available to, like, if the lake is anoxic at night, that is available to provide oxygen into the water column, particularly in the East Basin. The West Basin, it's about 59% of the total phosphorus is bioavailable. So that's the combination of organic and iron-bound phosphorus. In the East Basin, almost 70% of the phosphorus is bioavailable. And that's primarily because of the large pool of iron-bound phosphorus. So if the lake does go anoxic at night. There's a lot of iron-bound phosphorus down there available to release phosphorus up into the water column for it to be then mixed back up into the shallower water during the day to feed algae blooms and cyanobacteria blooms. So another factor that can cause internal loading is high pH. So iron-bound phosphorus isn't really affected by high pH, but aluminum-bound phosphorus is. And we saw on the previous slide, in the green here, there's a fairly large pool of aluminum-bound phosphorus in our sediment. And at a pH above 8, you start to, that aluminum phosphorus complex starts to break down. So not only do you have the potential for anoxic sediment at night to be releasing phosphorus from the iron during the day, or in the day and at night, if the pH is above 8, it's going to cause aluminum to release phosphorus. And the pH, the driver of pH in lakes, the reason that it gets really high is through photosynthesis and the transforming of carbon during the photosynthetic process that adds carbon to the lake and increases photosynthesis. I'm sorry, increases the pH. So we had pH numbers of up around 9. So we certainly were getting releases from breaking down of that aluminum and phosphorus complex with the high pH. And then kind of going back a little bit to our talk about Anabaena as being a nitrogen fixing species. Another interesting thing we noted was the phosphorus concentration was relatively high. Orange line is the total phosphorus concentration, and this gray line is our nitrogen to phosphorus ratio. Now remember, we had high phosphorus in the lake during the summer and high nitrogen in the lake during the winter. And so the ideal ratio for organisms to utilize phosphorus and nitrogen is 16 parts nitrogen to 1 part phosphorus. And so that's the, and usually lakes are phosphorus limited because there is there's adequate nitrogen in the water body to there's plenty of nitrogen in the water body. But in this one, in Weiser Lake, it was interesting. It was because there was so much phosphorus in the water body that the organisms might be nitrogen limited, which is important because Anabaena is a nitrogen fixing cyanobacteria species, which has the ability to fix atmosphere. If the nitrogen in the water is too low, it can fix atmospheric nitrogen to make up for that deficit. So that might be a factor in why we had such a large cyanobacteria, particularly Anabaena bloom. And then also we had very low transparency in the lake, and so there wasn't really the ability for algae to be able to, they were limited in the light that they were able to be exposed to because the transparency was so low. So um, that kind of that inhibited the total algal, the other algal composition in the lake, and maybe favored cyanobacteria because they can regulate their buoyancy and reach the depths that have the best light or the best nutrients, or they can make their own nitrogen. So they are particularly resilient for surviving in lots of marginal conditions. But also, depending on the time of the year and the factor of the wind, there is a possibility that the wind could be disrupting the cyanobacteria's ability to regulate its buoyancy. And so we had the one in October, and in the October 10th sampling day is when we saw the really large cyanobacteria activity. And maybe earlier on in the year, there wasn't that much of it there because maybe there was enough wind and enough mixing during the day that the cyanobacteria weren't able to regulate their buoyancy and overcome the mixing by the wind. So that's another factor we were considering. All right, so our nutrient data summary. So we had high summer phosphorus. I know that was a lot to take in. I apologize, but thank you for your patience. High summer phosphorus from internal loading, sediment resuspension if the wind is mixing up the sediment and bringing phosphorus up into the water column. Potential for anoxic sediment at night, releasing phosphorus from iron and through diurnal, and then high pH, also releasing phosphorus, but from aluminum this time. And then cyanobacteria, despite the high phosphorus, the overall phytoplankton growth might have been nitrogen and light limited in summer. But the cyanobacteria, because they were nitrogen fixing, could overcome that. And there might have been times of the year when the wind mixing was reducing the ability for cyanobacteria to adjust its buoyancy and become dominant. All right. So now this is our first Q&A break. So I know that was a lot to take in, but if you folks have any questions or clarification questions, or now's the time to ask.
Everyone's asleep, Mark.
I think so, yeah.
They had their dinner.
The middle of the food coma. I have such a soothing, calming voice.
I think all of us would be interested in those of you who live around or use the lake. What's been your experience around the lake? Is anything that Mark has described inconsistent with your understanding of the lake? Are there other water quality concerns that you're aware of at the lake that we're not capturing in this analysis? We'd love to hear it.
And in particular, interested in hearing, okay, we're looking at the Bellingham Airport and calm winds at night. Just wanted to see, is that the experience that you folks living around the lake, is that your experience, that things really calm down at night and the lake is just flat calm and really placid?
Hi, we live on the lake, and our experience is that the winds do not calm down at night. We have Weiser Lake has got some of the most incredible winds that come through it. And sometimes at night you look out in the water, it's like it's got little rapids. I mean, we have some crazy winds at times. And where we live we're on the southeast side of the lake, and we get algae so bad in the summer like as you were talking about in August, it's literally like it's super thick and it goes out quite a ways. It's really dramatic, worse on I think on our side, than I've seen it on even on the other side. So it's pretty aggressive.
And the southeast side of the lake, yeah, so the southeast side on the main basin. Okay, yeah.
Yes. Yep. Yeah, it's really thick and yeah, we've actually had to go out and try it. We had neighbors that used to have a machine that would come in and try to break up all of the weeds that we got out in front. And then he moved away a few years ago, so we don't have that machine anymore. But it's really bad. I mean, you cannot swim in the water.
And is that so? Since it's really windy, is it like blowing straight down the lake from the west to the east, or
East to west.
oh,
East to
okay.
west.
East to west. And even like in the winter, like even now with the snow drifts, we get snow drifts from the wind so bad that even our last snow, we could not even open our front door. It was that bad. That's how bad it is. Also, are you guys aware of what has happened over the years with the dam and the farmers playing
No.
around with the
Do
water?
tell. Do tell.
Yeah.
Oh, do tell. Okay, well, I'm going to let my husband explain.
Well, I guess in the year 1980, they built a dam over here, over on the it'd be the east side, on the other side of the bridge, which helps regulate the flow of water. Which sometimes is because what happens sometimes in the middle of the peak of the summer, the water level is so low. Because I know there's probably not a lot of water coming in too, and then you toss in the fowl in there, the waterfowl, plus you're down about 3 or 4 feet of water. And that's when it really can get bad too, during those July, August months where you can't even go down by the lake because the smell is so bad. And you look inside around the beach here and you see the little dead fish caught in the little, in the shallows there and there. Yeah. So, but then that's when people are actually trying to use the lake out there too. When you start getting the reports how toxic the lake level is, make sure no one goes in there and uses it too. But, wintertime, it's not bad. You have to full pool pretty much with the rains.
Talking about the dam.
And the dam, well, I'm not sure how the dam, I think it has a level where if it releases it over the edge and the farmers draw during the summer for, irrigation. And,
Okay, my husband doesn't want to say too much, but I'll say a little bit more. Our, basically, we've been here for over 20 years, and there was a huge problem here with farmers going out. Some farmers had regulated the water. There is on the west side, there's an actual dam and a valve area. And what was happening is that water was being played around with, and that was changing the level of the lake. And there have been neighbors over the years that have tried to address that and fight that, but there definitely has been a water dam issue.
Got it.
I have
Super
something to say
helpful.
about, sorry, I didn't mean to interrupt. I was just wanted to piggyback off that dam comment there. I've lived here for about 8 years now, and I've noticed that I've gone down to the dam several times to try and just our little like 14-foot aluminum boat. We can just roll down there. And I've noticed that beavers will dam up down there and completely block off the water flow. And I know at one point I've heard of just like plywood boards actually being put up against the dam. I heard that happen before. I didn't see it, but I heard of that. So someone tampering with that. I'm not sure how that that impact or whoever put that there. I've just heard about that, but I do know that beavers are a big and what or little animals putting things there is a big thing. I've gone down and moved stuff around down there a number of times and just kind of seen how it's changed and what happens down there. That's kind of wanted to throw that in there.
Awesome. Thank you, Evan. We have a hand up with Driscoll's, I believe it's called.
Yeah, hello. My name is Ross. I live on the lake. And I just wanted to clarify, our predominant wind here is the southeast direction. It blows that way most of the year. In the summer, it does switch over to the west a little bit, and it'll blow down the gut of the lake from the west side to the east side. So when we talk about wind direction, I talk about where it comes from. Just okay. So and I know it does get when it blows southeast, The other side of the lake sees a lot of chop, this and that. This side of the lake is on the lee of the wind, or the south side is on the lee of the wind. And then wintertime, it can start in the early fall sometimes, but we, depending on the pressure gradient, we'll get northeast winds. And that's when it gets really turbulent in the lake. You know, if the wind does stop at night and it's still cool, it'll freeze and all that stuff. But I guess I just had a question about what you were talking about having to improve stratification. And is that what we're kind of looking at here?
Well,
Yeah, no, actually, Ross, it's a good question. That was kind of and I don't, so stratification, we don't really, in the situation of Weiser Lake, we don't really want stratification, because what happens then is that's what causes sediment, the bottom of the lake to be without oxygen, and then phosphorus to be released from the sediment. So we don't want stratification. And so that's why I was getting at. I was really interested in knowing your experiences, whether or not the winds do calm down, like at midnight, 1, 2, 3 in the morning or something like that. Do they calm down enough so that you could get a situation where the surface is separated from the bottom and oxygen is depleted and nutrients come out of the sediment? So yeah, in answer to your question, we if a management activity wouldn't be to cause stratification, but would be to make sure that stratification doesn't happen.
Okay,
yeah,
thank you.
and
Yeah, so it just depends on the time of the year and the seasons if the wind calms down in the evenings. Typically, your summertime, if you're not having a system, come through, like a low off of the coast that's coming through, and it does calm down during the evening. When the northeast winds blows here, it blows sometimes 3, 4, or 5 days straight. So that's what I've seen.
awesome. Thank you so much. I want to go to the chat real quickly because some folks have posted a few things and I am capturing them. But Paul, you mentioned that it's calm at night. Can you speak, Paul, just quickly? Which part of the lake in general? Southeast, northeast? Where would you say you are along the lake?
Yes, West Weiser Lake, and it does calm it in the evening.
Perfect. Thank you. Yeah, all of this helps because we can obviously get weather data, right? And not just from the Bellingham Airport. And we have acquired data from closer to the lake. But just because we get it, even if it's 100 yards away, doesn't mean that's what the lake experiences. So we appreciate all the feedback. Dixie, thank you for all your comments. I've captured those. They're in my notes now. Super, super helpful. Mark, there is a question from Kay. How do the nutrient levels compare to toxin levels during the time frame that the data were collected? So I think Kay might be referring to not either the toxin levels of the algae or the toxin levels maybe of the nutrients themselves, if the nutrients are high enough to be a toxic issue. So you might want to address both.
Yeah, so the toxin, it's a little bit of apples to oranges, only because when they collected toxin data from the lake, they grabbed it from the boat ramp, and the boat ramp is historically, from what I understand, is kind of an area where stuff tends to accumulate. And so you're going to have a higher concentration there at the boat ramp than what you would have out in the lake where you were sampling. But regardless, during the Anabaena blooms in July and in October, if there's a high concentration of cyanobacteria in the lake. And what cyanobacteria do, because they can adjust their buoyancy, and then when they start to die off or when they get stressed, they rise to the top, and then they can get blown to the shore, where they can be picked up, particularly in the boat ramp if they're sampling, where they can get picked up and show a really high concentration. So yeah, does it correlate exactly with what they were collecting for the toxin data? I don't know if it's exact, but since there was cyanobacteria in the lake and it tends to blow towards the boat ramp, then yeah, I don't know if there was an exact correlation. I don't know if that helped or not.
And I'd like to say that is one of the, not requirements, but recommendations with regard to sampling is to get, the worst possible case, if you will. So they are supposed to take samples from a nice thick mat.
And also because the boat ramp is the place where most people interact with the lake. So it makes perfect sense that that is where they would collect these samples. And if they're, if they're sampling at a lake, it's typically a public boat dock or a public boat ramp or something like that, where there's going to be the highest risk of exposure. So yeah, that's where they should have been. They were correct in sampling them there.
Yeah. So, Evan, thank you for your comments. Not surprised about the silty nature of the sediment at the bottom of the lake. That is definitely a factor, and it's something that's important for Mark's comment earlier about the sediment bed potentially releasing phosphorus into the water column. Because what happens is if you've got really super soft sediments that are not compacted, then that allows a lot of water to go between those spaces in the sediments. And if the dissolved oxygen goes low, then it may not be just the top surface. It could be deeper down that's actually releasing phosphorus into the water column. So awesome note, Evan. Thank you. Dixie, you mentioned a question here. She says, you mentioned a couple of metals. What influence of lead from lead shot could be occurring? So I take it from Dixie that people are shooting their guns over the lake. Is that true? Was there any actual lead sampling?
No, there was no lead sampling. And that's a really good question. I don't know if lead binds with phosphorus other than being, toxic in general. I don't know that it binds with if it binds with phosphorus. And quite frankly, I don't. Yeah, I don't really. There's no. Yeah.
But we did have aluminum and we did have iron, correct?
Iron. Yeah. Mm-hmm.
Iron. Okay.
And the reason for those, because they are known to bind with phosphorus. And so when they go through these panels, and likely lead wouldn't have been picked up if it's just from lead shot in the lake. That's not going to be equally dispersed throughout the water body. It's going to be concentrated wherever that lead shot lands. So you're not going to be able to, you wouldn't likely pick it up in your sample anyway, unless you happen to, there happened to be lead shot right there in that location where you're sampling.
Yeah, Craig mentioned in the notes that there's a one-to-one relationship between water depth and water quality during the summer. Totally agree. We've seen that time and time again on lakes, that when the water level in a lake is going down, that volume decreases, you have more exposed shorelines, etc. That it doesn't take much to then have the lake go from not being so productive to being productive, meaning more algae. And so absolutely, certainly when the lake is full and it's full of water, that's one thing. But when that lake level goes down and it shrinks, you're basically concentrating the nutrients you do have either through water loss and evaporation, but you still have the opportunity, quote unquote, to have lots of algal production occur. So all good comments and notes, and I've captured that. Also, a couple people pointed out that they can't hunt ducks at the lake. It's part of the bird sanctuary. And Craig mentioned just now, the water level is easily controllable at the dam. Yep, totally agree.
Now, Craig, so when you say easily controllable, so there's like a valve or something there, but are there times when, like, I was been out at that control structure and there's screening around it. I think that's to keep like the beaver from building dams and stuff, but does that become plugged up with plant material and stuff like that and cause water fluctuations?
Yeah, I think that there's activity that goes on over there that allows it to retain more water in the lake. Given that fact, it tells me that it can be controlled even during the drier months of the year. So if you were to create more control at that dam to where you could control the water level, then you could improve the water quality.
Yeah, that's something that if we, and we'll talk about that in a minute in terms of the water budget, but certainly, as you know, we're in the Pacific Northwest when we get our rain and when we don't. And if there's an opportunity to do something like that where you can capture the water and keep the lake full during the summer, that obviously will impact the water quality. So awesome things to point out, seriously. So.
In addition to that, I introduced 2 aerators into my lake, into the area in front of my property on the southeast side of the lake. And I saw a night and day difference in water quality starting in May all the way through summer. I could see golf balls, probably 5 feet deep in the water. And then the wildlife, the number of fish was just booming around my dock and around my waterfront.
So you said you had 2 aerators that you put in, is that correct?
Yes. Yeah. When I first put them in, the watercolor was kind of brown. And within a month, it was basically black. Not black, the color, but black with clarity. You know what I mean?
Oh, I see.
It was markedly different. And it was just 2 aerators that handle about 3 acres. And then I had no vegetation growth. Any vegetation that came through there was transient. And nothing was rooted to the ground. And yeah, it was the best year by far that I've ever had. And I've lived there since 2016. So I shared photos with you guys. I don't know.
Yeah,
if it made it.
I did see those. Yeah, thanks, Craig. And what is the extent of the vegetation on the lake? Like if it's really loose sediment, then it wouldn't seem to me that there would be much for the roots to grab onto to hold plants in place. Is there, what is your experience? Is like what percentage of the lake has plants in it, in your estimation?
I would say 90% of the lake has it around the perimeter for sure.
Around the perimeter.
Throughout the summer months. Yeah. Probably starting in August, especially September. Peaks late September, early October. And then everything cools down and then everything dies off and settles out. So I think that the sediment makeup as well is vastly different from the south side of the lake versus the north side of the lake, because the prevailing wind is coming out of the south and then heading east. So it's coming southeast. So as the wind, which is predominantly, majority of the wind comes out of the south, then it pushes all sediment to the north side of the lake. And then that's where everything settles out. So everything goes to die on the north side of the lake. So the south side of the lake tends to be better anyways. But with those aerators, by introducing the oxygen, it greatly improved the water quality and clarity. And we were able to use, and my kids were out in the water basically all the way through August. And we didn't have to, rake up any leaves or rake up any, algae or whatever those things are, so.
Awesome. I'd like to go to a question on the chat, and then we'll go to the hand that's raised. Jennifer in the chat asked, was the required minimum lake level maintained during the study? The study being when the data was collected. I don't personally have that information. So I'm wondering if either Anna or Josh at the county or Mark or Elizabeth happen to know.
Yeah, I don't know what I don't know if the minimum level, I don't, is there an established minimum level for the lake? I don't know that.
I think 50 feet is the minimum. And I don't know if the lake level was maintained either. I don't know.
Awesome. So I think no, that's super helpful, everyone. I'm trying to keep up with all the comments. There's a lot of good comments about pond weeds and things like that. So there was a comment here from Craig about there was litigation, but we'll come back to that in a minute. We have a hand raised. I want to pronounce your name correctly. Satpal?
Hi, good evening, everybody. My question was same about the level of the lake that maybe it doesn't exist right now, the minimum level height or anything. Can we introduce that and maintain a lower level for, say, 2 years at a time, and then do the study so that we know that it holds good, that if the level is dropped by 3 to 4 feet, how it impacts the quality, water quality.
Yeah, that's a great point. Seriously. Obviously any data collection takes time and money and resources to make it happen, but it's still a good point that if there's the opportunity going forward to take measurements under different lake conditions, summer when the lake's full or when it's really dry and low, all of those can provide insights. So, yeah.
And Rob, just to clarify, I meant 50-foot elevation, not 50 foot. Yeah,
yeah.
Wiser.
I figured, yeah.
Yeah, we all know Wiser is a lot shallower than 50 feet.
These are all really good points. So, Craig, when you talked about the litigation for the lake level, so basically, was this something where the farmer sued in order to get more water, to use water from the lake because of drought, or was it a different set of circumstances, to your knowledge? Not that I expect you to be the expert, I'm just asking.
Yeah, that was my understanding, was that there was litigation with competing interests. One was to keep the water level high. The other was for the farmers' need to irrigate.
Yeah.
So there was 2 elevations that were agreed to. What they are exactly, I'm not sure. But there was a different elevation for summer versus winter.
Got it.
So the winter elevation is higher. Summer elevation, they allow it to draw down further.
Interesting. And it looks like JPB put in the check dam at the west end of the lake is set at a certain height by law. As mentioned earlier, rodents may make changes that affect how much water actually flows over the check. Awesome, super insightful. If we will probably need to look into that, because obviously if the lake level is required to be at certain levels in certain seasons by law, that obviously limits some of the ability to operate the check dam as a way to help with water quality. Doesn't necessarily make it zero or can't be helpful at all. It's just something we'll want to think about moving forward. So all of this information is super, super helpful and very much appreciated. No one person can know it all, so getting your feedback is brilliant. So awesome. Should we continue?
If you
Please,
look at
Craig.
if you look at the water level and water quality back in 2016, there was a significant drop in the water level in 2016.
Yeah.
And that's when I think we had our first toxic bloom.
Got it. Yeah, I saved all your
we were
notes.
aware of that was, public, made public. So.
Totally. This is awesome. I'm capturing all these comments and organizing them by speaker, just so that we pull all the information together. So super helpful. Any final thoughts before we go on to section 2, which is what I'll be talking about? Awesome. Let's keep going then. So what I was hoping to talk a little bit about is Mark spoke about a lot of the data that was collected and was able to break it down over time from the different samples. My job was to sort of pull that data together to look at an annual water budget and an annual nutrient budget. The idea is to sort of capture system-wide what we think might be going on in terms of the influences on the water budget and the nutrients coming into the lake. And then I'll wrap up a little bit with, I just have a few slides. We'll talk a little bit about a conceptual model that's sort of like what we think the big picture is for the lake. And then we'll have another chance for a Q&A here. So next slide. So what we did is we basically looked at the different influences on what are inflows to the lake and what are outflows to the lake. And we identified in this little table on the left, the lake inflows, obviously the stream flow itself, the precipitation given the relatively shallow depth, it's not all shallow, but the large surface area, we wanted to capture that. We also want to get some sense of groundwater. That's on a net basis because we didn't do some complicated groundwater model. And then overland flow. And what we mean by that is the immediate drainage area around the lake, as opposed to what's coming from the upstream watershed. And then for the outflow, we obviously have some loss from evaporation, which we can calculate. And then the lake outlet itself became sort of a knob to turn, if you will. There were some measurements, but the idea was to make sure that the water balance occurred between the inlet and the outlet. And so if you look in that table, each of those components are listed, and then we have what acre feet as a volume. If you love the metric system, there's cubic meters. And then from the total from the inflow components and the outlet components are summed up there at about 1,100 acre feet. If you look in the upper right, the pie chart is really just breaking up those inflow components to show you like the percentage of the total. And so here what we see is that the stream flow is a huge percentage of the total. It's 56% of the water that's coming in, and then the next largest is 24%. Obviously, we don't control the rain, but certainly overland flow and stream inflow and groundwater are components that we can potentially influence. Not so much in terms of the quantity of water, but just understanding that those are the mechanisms that transport things into the lake, such as the nutrients that we're concerned about. Next slide, please. So one of the things that Mark hinted to earlier is waterfowl, and this is just another chart. It's really busy, but the idea is that each of those bars represents one of the sample events where someone went out and did a survey and counted birds. And so we grouped them by ducks, geese, and swan, and then other. And you can see that they're in the spring, in March, April, you can see there's a huge chunk of the waterfowl are in fact other, in the other category. But a large chunks of the year, you see ducks and geese and swans are the predominant species. There's a variety. The survey data was super useful, but it was limited to simply bird counts at each of those dates. So we totally appreciate it. It's valuable data, but it's not a perfect world that we live in. And so the issue is that we looked at the literature, we looked at other people's strategies on how they took bird counts and other information and converted that into what's the nutrient load, if you will, to the lake due to these waterfowl. The challenge is simply that there are different approaches, and we didn't have all the data that are needed for these different approaches. So for example, some of these approaches used samples that they collected in the field at a different lake, maybe in Michigan or somewhere else in the country, and they said, oh, the amount of fecal matter that a duck or a goose gives off in a given day is 1.75% of their body mass. Okay, how did they figure that out? They don't tell you in the literature. So is that applicable at Weiser Lake? Maybe, maybe not. In addition, we don't know from the data how much the waterfowl were actually on the lake as opposed to adjacent to the lake in the fields around it. Why does that matter? Well, if the ducks and geese are feeding off things in the lake, they're literally removing nutrients, but if they're defecating on the ground nearby, then that's not technically in the lake, but it could be a nutrient source that goes to groundwater or overland flow. And so it gets really complicated really fast. And so we found from the literature and other studies that literally it could be anywhere from 27% all the way up to 70% of a nutrient budget for a lake if you have the right information to calculate it. And we just didn't feel like we had all that right information. In the draft lake management plan that you'll eventually get to see, we do attempt to calculate some numbers there. We just didn't have enough confidence that we could nail it down to the point where we said this should be a component of the pie chart for the nutrient budget. The other piece to think about is simply what they call nutrient cycling, is if you do have, for example, ducks that predominantly are out on the lake and they're feeding from the lake and they're defecating in the lake, that's really just the nutrient cycling within the lake. It's not like a new contribution. And so that complicates the matter as well. In an ideal world, you would have lots more data to go with simple bird counts. We just didn't have that data. We just definitely think this is valuable. It shouldn't go away as something for us to be thinking about with the lake management. It's just really hard for us to quantify this is how many pounds of nitrogen and phosphorus are getting in the lake due to the waterfowl. So I wanted to throw that out there before we get to the actual nutrient budget, which is the next slide.
Yeah, hold on.
Mark's got drawings on there.
Yeah, I don't know where those came from. I had to get rid of those first. Ah, come on. Oh, maybe that's it. There we go. All right. Sorry about that.
So again, this is on an annual basis, taking the data that was collected. And so on the left-hand side, we have the nitrogen budget. As Mark had indicated in the data, there tends to be a large amount of nitrogen that occurs in the wintertime, whereas the phosphorus tends to occur more in the summertime. And so what we see here is in the nitrogen budget that 79% of the nitrogen coming into the lake is literally coming from the upstream watershed. And another 12% is coming from the land directly around the lake itself. So that's a huge proportion of the nitrogen loading to the lake. When we look at the phosphorus budget, it's much more dispersed. And you can see that in there. The stream inflow is 30%, the overland flow is 27%, internal loading coming from the sediment bed is a good 24%. Now, obviously, all of these numbers have some uncertainty, but we're not going to move from the stream inflow of 30% to 80%. It's going to be plus or minus a few percentage points. And so I wouldn't get fixated on the exact number, but understanding that there is a component. And you can see in here that we've also tried to include septic. That is uncertain as well, because some of the septic systems in your community have been well maintained, others are overdue for inspection, but just because it hasn't been inspected doesn't mean it's a problem. So there's a lot of uncertainty around that. But certainly from a phosphorus standpoint, the septic is larger than it is for the nitrogen component. And so if we're thinking about holistically the whole lake, certainly things like around the lake, that overland flow piece and the upstream watershed can be quite significant in terms of their influence on the nutrients in the lake itself. Okay,
And
next slide. Oh, please.
And I
Mark.
just wanted to, while we're looking at this, I wanted to also remind folks, this is an annual budget. And so these numbers are going to be a little bit different. Like if we just wanted to find out what is our internal loading on an annual basis is 24%, give or take. But if we split that down to just the summer component where we don't have as much stream flow, then that internal component could be much larger.
Correct. Yeah,
so
totally agree with you on that, Mark. It's a really good point. These are annual numbers. Obviously, if we had something like 10 years of data, then you could break it down into seasons and get really granular and have some confidence that you understand, oh yeah, that internal load starts on, mid-July and goes through mid-September or something like that. But because we only have 1 year, which is still awesome, it's not like we can do all that kind of detailed analysis and have a high level of confidence. So next slide, if you would, please. So one of the other things we wanted to do, these, what they call the Vollenweider and Nuremberg model, these are very simple little spreadsheet models that look at the whole lake, again, on an annual basis. But the idea is to say, if we understand things like the lake volume and the loading to the lake, what would be the estimated concentration of phosphorus in the lake? And so using these two approaches, and the Nuremberg model is a little bit more detailed because you can see at the bottom of that table, it shows you like an annual average phosphorus concentration. It shows you a summer epilimnion and a fall concentration. The idea though behind these two tools is simply, if they're really close, and I think they are when you look at the data that's in the bottom left corner, yes, the numbers are somewhat different, but they're relatively close. And so the utility of these kind of tools is, if you start to look at, well, what if we reduce the loading from the watershed by 20%? You can play games in these little spreadsheets to say, how much does that change the number? So it's less important that it's exact to the data you collected that may be unique to a given year, and more valuable to be able to say, oh, if we did a 20% phosphorus load reduction from the watershed component that was in the pie charts you just saw, how much would that number of 74.4 or 75.6 change? Does it drop it by 20% in the lake, or is it only 10% in the lake? So that's where this tool can be a little bit useful. And again, because the two between them came very close, closer than we expected, that gives us a little bit of confidence that we at least understand the large scale physical processes that are influencing the nutrients in the lake, if that makes sense to folks.
And also that another kind of one kind of benefit of this too is that it also kind of illustrates where there's some data gaps that need to be filled in. Like if you want to improve your estimation of what external loading, internal loading, then it's like, okay, really we could be collecting this data to really kind of nail that number down. And over years, like Roberts had mentioned earlier, with 10 years of data, then we can really start to parse out where things are happening, and to get that little bit better level of accuracy, then these models kind of steer you in the direction of what needs to be collected in order to improve the outcomes.
But I also want to point out, Mark's absolutely right, but I also want to point out that there's always additional data can always be helpful, but it's also not mandatory, right? I want to be clear about that you don't have to wait until you've collected 10 years of data or even 2 years of data to then be able to start making decisions about how you want to improve the lake water quality. The point is just that depending on how detailed of information you need, or if you were to implement some strategy in the future and it doesn't turn out to be as effective as you thought it would be, there might be a reason why. And some additional data might help you figure that out at some point. And so it's a little bit of an iterative process that as you learn more about the lake, you may decide that more data is needed, while simultaneously you decide to implement some projects that can help improve lake water quality. So it's not like you have to do both or either or, but I just want to throw that out there, that it's not about that you have to have lots of data. I think we've got an awesome start with the data we've collected, and it's given us tons of insights for now. Next slide, please. So this is just a summary. So the water budget, no surprise to everyone, is dominated by the inflows and outflows. There really wasn't enough information for us to come up with an accurate nutrient loading that might be associated with the waterfowl. That doesn't mean we can't keep trying. We do know that some of those, a large fraction, I think some of the literature we saw was 80% of the waterfowl droppings tend to get internally cycled within the lake. The nitrogen budget itself is dominated by the stream inflow. The phosphorus budget is dominated by the inflow and the outflow, and definitely the internal loading when it's in the summertime. And the analytical models we just discussed are really useful for estimating those current conditions, but then using it to assess load reductions that might be required to improve water quality, or simply evaluating different management options. How much does it move the needle for improving the lake water quality? And then lastly, on the next slide is just summarizing both from Mark's section and mine a little bit about the conceptual model for the lake, where we do talk about those large nitrogen loadings in the wintertime. You see that in the pie chart that shows up on the annual basis. And then we see the large phosphorus that occurs in the summer due to sediments. Again, that shows up in the overall pie chart, not as a dominant component, but certainly a strong component. And then why we think that's occurring in the summer. And then we're going to get into some management options. But the idea is that some watershed improvements, those things that help on the overland and the inflow coming from upstream in the watershed, those might be longer term strategies, because it does take time to put things in on the ground, to sequester those nutrients and reduce the loading that eventually gets to the lake. There might be strategies that are more short term, that are more local to the lake itself. Then we'll certainly talk about those as well. But just kind of setting that up for you, that as we get into the management piece, which we'll talk about after the next break, but again, there are different options for looking at these different components of the budgets, if that makes sense to folks. So this is our Q&A again. Questions? Is there things that are not clear about this conceptual model of what we're understanding going on at the lake, whether it's on an annual or seasonal basis? Are there additional concerns that haven't been brought up yet that you're interested in raising now? What do folks think?
And it's 7:35, so we can let you folks kind of think about this, and then we'll just have a broader discussion towards the end.
Yeah, we can do that.
So that we can make sure to get through Elizabeth's section, and then the next section of the management activities. So.
And you can definitely put things in the chat. I'm monitoring the chat, so feel
That's
free
a
to
good
ask
idea.
questions at any point.
So we're going to move on here to our management options to, you know, again, these are not things that we're saying this is what you need to do in order to solve your problems. These are things that we're thinking about based on the information that we have so far. So again, we talked about our short-term and our long-term management options. Short-term is phosphorus, and we'll go into details in some of these in the next few slides, but phosphorus sequestration, which means binding that phosphorus that's in the sediment, aeration, making sure that the water column stays circulated, reducing our waterfowl population, reducing or discouraging Canadian geese residency. You know, they're supposed to migrate, but a lot of times they just stay around year round. And then algicides. Now those are kind of short term, because although reducing waterfowl and discouraging the geese, that affects the watershed, but it also affects the lake proper, because if they're if they're landing and defecating in the lake, like Rob was saying, they're going to be contributing phosphorus. Now, our long-term projects, long-term options, updating the septic tanks so that they are properly functioning, introducing some agricultural BMPs to make sure that fertilizers are used properly and aren't running off. Public education about the proper use of lawn fertilizers and how to best take care of the lake, and to reduce manure applications in the watershed. Now, I don't know if the manure applications are currently happening in the broader Cougar Creek watershed, but I know there is a history of manure applications, certainly in the groundwater area that is feeding Weiser Lake, maybe not specifically to the immediate watershed, but certainly in the broader context. And so a little bit more specificity here. So phosphorus sequestration, this is a table showing, you know, all of the management options that we were considering. Phosphorus sequestration, we talked about that. The two options, aluminum sulfate and Utrosorb. We'll talk a little bit more in detail about those later. Aeration, again, if the lake does stratify and the sediment is anoxic at night, maybe that's an option. We talked about fish removal. I don't know if there's a high population of bottom feeding fish that are disturbing the sediment. That might not be a huge component of sediment or phosphorus release, but in some lakes it is. Dredging, no. Oxygenation system, that we didn't feel that would be the best. That's similar to aeration, but it injects pure oxygen into the water, and they're quite expensive, and they take quite a bit of electricity to operate those. So they are best in situations where you want to maintain stratification, and that's not the case in Weiser Lake. Floating wetlands, kind of ruled those out just because of the number that would be required to remove the amount of phosphorus in here. You wouldn't have a whole lot of open lake left. Reducing waterfowl, as we discussed, yeah, that's reducing waterfowl, septic updates, the agriculture BMPs are recommended. Constructed wetlands, I don't think there's really not an area that you could create a wetland in the upland area to allow water to filter through before getting into the lake, because the Cougar Creek is pretty well incised, and so there's not really an opportunity to create an off-channel wetland. However, there may be in the future some opportunities to restore that stream, to reintroduce a meander and reintroduce the wetland function that it had before it was straightened in the land drain for agriculture. But that is, super long-term option. Again, public education, phosphorus-free fertilizer for folks living on the lake, suspend manure applications and discouraging geese. We saw this all earlier. Another option was to treat the phosphorus coming in from the creek, but during the summer, that is not the major source of phosphorus to the lake. So that's not really going to be a beneficial process. Now, there are ways that you can control cyanobacteria directly by algicides, endothal or peroxide. Now, those are certainly viable options, but the problem is they don't get at the cause of they are treating the symptom and not the cause, I guess is what I'm trying to say. So it's best to figure out why you have so much phosphorus in the lake and then try to treat that than using algicides, which don't reduce the phosphorus. They just kill the algae, and then the next couple of weeks you're right back in the same cycle again. So it's not a recommendation. Now, I put possibly in there because there may be certain areas, like if there's a high concentration in a very public area like the boat ramp and you want to do a temporary treatment to reduce the risk, then that is a possibility, but not lake-wide treatments. They're just not as effective. And so one management option is the waterfowl reduction, and I don't want to spend a whole lot of time on this. You folks will share this presentation with you, so you can go after, you can look at it in your own time. But there are several ways. Essentially, you want to discourage wildlife from feeding in the watershed, and try to discourage the easy movement between the water and the land. And so particularly at geese, if they see, if they're in the water and they have an easy passage to the land, they'll move back and forth pretty easily. But if there's higher vegetation on the shoreline that this disrupts those sight lines, that's one pretty effective way of reducing the geese movement and the waterfowl movement. But then aeration, we talked about that a little bit, and what that is essentially it's a bubbler that you place on the bottom of the lake, and it runs constantly and circulates the water from the bottom of the lake to the top of the lake. So essentially, it's doing what the wind is doing, but during the night or during time when the weather is calm and the wind is not doing that mixing for you, this maintains a fully mixed water column, so you have oxygen still down by the sediment to make sure that your phosphorus stays locked up. Now, we don't know if this is a viable option or not, because we don't know yet whether this lake is experiencing anoxia during certain times of the year. And so we need to collect more data in order to be able to make a firm recommendation on the where and how many aerators to put in this lake to maintain that circulation. But essentially, it's a compressor on shore with weighted lines, and then it's pretty simple, and then just bubblers down there that put bubbles in the water column and circulate it. Phosphorus sequestration, so that's we talked a little bit about that earlier. Aluminum sulfate, which aluminum sulfate, that's been used for decades for lakes, and that's what's happening on this lake in the picture. Going back and forth applying aluminum sulfate, it binds to phosphorus as it settles down into the water column, and it creates what's called a flock, and it actually strips algae from the water column and binds phosphorus on its way down, taking it to the sediment layer where it potentially locks it up for a long time. But like I said earlier, if you have high pH in the lake, pH above 8, then that phosphorus is released from the aluminum. So aluminum sulfate may not be the best option for this lake because of the high pH conditions. Utrizorb is a fairly recent product, and that uses lanthanum That's another mineral that binds phosphorus. And so that's been used quite a bit in Washington for treating lakes. And it doesn't strip the water column, but it also, one thing that, okay, I should mention here that aluminum sulfate, when you're applying it, it reduces the pH. That's why I put that up there. So, but it's still, while it reduces the pH while you're applying it, it doesn't mean that the pH is going to be low for the entire period that you're for the entire summer. So you still could get high conditions where your pH is high and phosphorus is released from the sediment. Also with aluminum sulfate, because it reduces pH, Ecology requires pretty extensive pre and post application monitoring to make sure you don't end up with a toxic dissolved aluminum in the water column. So that's another factor you have to consider when you're doing an alum application. Uchisorb, it doesn't reduce pH, so the monitoring component isn't a requirement. And then it has a higher tolerance for pH. The phosphorus is released at pH starting around 9.5. So you've got a little bit of headroom in Weiser Lake for if you're using Uchisorb with lanthanum, you have a little bit more headroom with your pH to be able to maintain that phosphorus binding capacity. So, and I was able to put together a list of costs for phosphorus sequestration because we know the phosphorus concentration, we know the volume of the lake, and so we were able to pretty easily put some numbers together. So the top chart is for an alum application. Again, this isn't recommended because of the pH, but I wanted to just give you the numbers anyway. A stripping dose, and that is just a simple dose where you're looking at the amount of you're looking at the phosphorus concentration in the lake. What would it take in order to remove the phosphorus concentration in the lake at that point in time? And that's what that number is. And there's a potential where you would have to do that several times over the course of the summer because you're doing a fairly light dose. Sediment treatment, added that in there because that's equivalent to what is happening in the chart below at the Uchisorb. So you're sequestering a certain amount of phosphorus when you're doing the sediment treatments. And so in order to compare apples to apples, it's about $115,000 for treating the sediment with alum and about $122,000 for treating it with Uchisorb. And again, just keep in mind that the Uchisorb has a higher pH tolerance. Rob, did you have a question or comment?
Yeah, I just wanted to reiterate something you said earlier to let folks know that, like, this is, while these solutions, you can see they're not cheap, they're also temporary, right? These are not long-term solutions in the sense that because water flows through this lake every year, you may treat it, you may see benefits for a couple of years, 3 years even, but then you'll be back to square one. So it doesn't get at the source of the problem. And yes, those estimates are for the whole lake, not just the east or west basin, they're for the whole lake. But so I just wanted to point that out to folks, not trying to discourage you or anything, but just so you go in eyes wide open, understanding that this could be a great solution for immediate benefit, but it would need to be done in coordination with, say, longer term solutions, so you don't have to keep paying this money every few years to treat the lake. I'll stop there.
Right. Yeah, and that's I'm glad you mentioned that because sediment treatment, this was calculated as an annual application. So like Rob said, you might be able to get away with with good conditions for a couple of years, but in order to be able to sequester the amount of phosphorus that's potentially released from the sediment, you'd need to add this much each resort product over the course of every year for several years. So the cost would really start to increase. But again, this is one option that's out there out of many. And then of course we talked about the watershed, septics, maintaining the upgrading septic systems, particularly in these shallow groundwater areas where the water table is pretty close to the drain fields. There are some advanced treatment systems that are now being developed for these shallow groundwater areas. This is an example of one that they're using out on Lake Newman, I believe it is, or Newman Lake. But at least to do a robust inspection and cleaning system of the existing septic installations. And then watershed BMPs, in addition to agricultural BMPs, but creating shoreline buffers, reducing lawn fertilizer use, establishing buffers between agriculture and streams, reducing manure, and increasing the buffer between the lake and the lawns, as you can see here. All things you can do. Again, these are kind of long-term projects or long-term options, but those are things if you want to maintain a healthy lake, you've got to do the combination of the long-term and the short-term. Long-term in particular, because it's not going to get better on its own. And we mentioned a couple of times about data gaps, and so one of the issues is, and this was mentioned a couple of times about the lake level, and I don't believe that there is a staff gauge on the lake to be able to really identify what the lake level is from one point to the other. So that would be really informative. And getting accurate inlet and outlet flow data, we talked about earlier how the model that's capturing the phosphorus from these different sources, being able to better gauge the inlet and outlet flow data would go a long ways towards improving that. And then in order to find out if the lake does have reduced oxygen at night, you can install some oxygen loggers over the course of a couple of weeks or a month or whatever, during a certain time of the year where it tends to get the wind speed tends to slow down during the night. We can validate whether or not that's a large component, and if that is, then we can move on to maybe aeration system or something like that to be able to maintain circulation, and then kind of continue with the data that are being collected already to try to again have a history of the conditions in the lake so that you have a little bit more of an idea of how certain conditions change based on the weather, based on what's happening in the watershed, to really start to track the activities on the lake and try and tie them to the watershed. And so, Anna, is there any way that we can go a little bit longer on this, or do we have a hard stop at 8?
No, I think we can go as long as folks are willing to stay on and you're available to present. I'm recording this meeting, so for folks who have to sign off, we're going to be posting this recording onto our website. And so if you missed the latter part of it, you can always refer to the recording. We'll also make this presentation available to folks. Mark, I think it would be great if you could just finish up the sections, obviously leaving some time for Q&As right now. But yeah, if folks are available to stay on longer, we'll make sure to touch on all of the parts of Mark's presentation.
So I'm going to leave these until the end then, and we'll move into Elizabeth's going to talk a little bit about some funding options for the things that we've talked about.
Oh, okay, great. Thank you, Mark. So just on the next 4 slides, and I'm going to speed through this. It shouldn't take me very long. We're going to go over some of the funding options as well as a few lake management options. And so on this table you see here, it extends to the next slide and also provides a list of potential grant opportunities, and some have loan opportunities that could assist with funding certain management options that you may or may not choose. The first 6 rows are from federal agencies, and therefore we are not sure of the status or what the status of those would be. The last couple rows move into some of the state agencies. Second column is a list of the name of the
Sorry.
program. No worries. Third column covers the management option that the grant program may consider. And the last column is the entity that is eligible to apply. This table can also be found in the Lake Cyanobacteria Management Plan, or LCMP. And one would be able to click on the name of the grant program and go directly to the website, so you can get more information on the RFPs and the dates available, the maximum grant amount, etc. And so the next slide is just the continuation of that table. All of these are grant programs within a couple of state agencies, as you see, Department of Ecology and RCO. And they may or may not be applicable to some of the management options that you may choose. And you can see that the primarily the eligible entities are state and local agencies or governments and special purpose districts, which does include lake management districts, which I'm going to go over next. Nonprofit organizations are only eligible for a few of the grants that are listed, and that will make a bit more sense as I discuss this next slide, which goes over lake associations. They are typically 501c3 nonprofits formed to protect a specific lake. In some cases, the associations are structured similarly to HOAs and are instead 501c4 organizations. Typically, lake associations play a critical role in lake production through fundraising, education and outreach, collaboration with local government and regional partners. Some of the advantages are that you're not really bound by county policies, meaning, the county policies associated with funds, like rules such as, putting out RFPs, etc. A lake association doesn't have to abide by those. Some of the disadvantages, as I mentioned just now, nonprofits are typically not eligible for very many of the grant opportunities out there. And so on the next slide, this is covering lake management districts. It was implemented with the RCW 36.61. It was enacted by the state ledge in 1985. And it was determined that the environmental, recreational, and aesthetic values of many of the state's lakes are threatened by eutrophication and other deterioration. So the purpose was to establish a governmental mechanism by which property owners can embark on a program of lake improvement and maintenance for their and their general public's benefit, health, and welfare. And it's important to note that the intent of this RCW was noted as an ecosystem-based management approach to promote the health of the aquatic ecosystem, and that management approach should retain ecosystem values within the Washington state. And the focus was long-term strategies that focus on reducing nutrient inputs. This is funded by special assessments, and any county may be able to create an LMD, a lake management district. It's initiated by resolution of intention by any city, town, or county, and also or by a petition signed by 10 landowners or the owners of at least 20% of the acreage of the proposed district. And the process goes on after that. There's a great website called MRSC that can cover this whole entire process, and that information will be also in the LCMP. And I'm going to stop there. We can go to the next slide and answer any questions for section 3 or section 4.
Can we go to the last slide, which is the next steps? I want people to get that, and we can certainly take questions about section 3, 4, anything we presented tonight. But we did want to make sure that you knew that, there's going to be an in-person meeting on April 1st. There's additional opportunities to provide public comment. This is not the only event. So I just want to make sure that folks got that message before they might sign off. So.
Any new questions or concerns, comments?
Paul asked, is the lake county owned? Well, the lake and the creek would be considered waters of the US. And in Washington and Oregon and most states, the land underneath the water is used for surface water is usually considered to be state lands, is my understanding.
And typically in Washington State, that's DNR, Department of Natural Resources.
So in this case, it's the land itself may be state. The waters are waters of the US, which is a federal thing. But it's not really something where the county or the state just says, one, we've got the budget, the resources, and we're going to just fix the problem. So. Another question was asked, how would our county exec seek funding to manage the lake? Well, that's just it. There isn't, what Elizabeth was presenting was the option of a lake association, which would be like a nonprofit, almost like a watershed council that the community could create and be eligible for some grants and not others. If it's done as a lake district, which is part of what would be part of Whatcom County, who would administrate the funding and organization of it, then that's another pathway one could go. We're not here to say which is better or which is perfect, but obviously you all know that whether it's the state, the county, a city, they all have limited funds. No one has an unlimited budget where they can say spend a lot of money. And so oftentimes what other lakes have done is a cooperative approach where maybe there's a lake district, maybe there's a lake association, maybe there's a watershed council. But all of those strategies can be supportive of either finding funding or raising money to do these kind of things. So, and we can certainly talk about that more at the April 1st event, which will be in person. You get to see our bright smiling faces in person for that event. But yeah.
Yeah, and then also several lakes, gosh, a good at least half a dozen, if not more, in Washington State have had their representatives go straight to the ledge asking for funds to work on lakes. Vancouver Lake is one example.
Lackamas Lake is another.
Yes, and they were awarded. I'm not sure if that would be the case now since there is a state deficit. But other ways would be for the county to apply for additional grants funds using that table that we provided.
Yep.
What are your
There's
thoughts,
a couple
Rob,
different
on the aerator? If every waterfront property owner installed aerators, what do you think the impact would be? I think that depends on whether it's internal loading that's causing the problem. And you found that quite a bit, over 50-something% was from the creek.
Yeah, so it could definitely provide some benefits, but again, if everyone did it around the shoreline, that may provide some localized benefits along the shoreline, but it may not handle what's going on in the lake. It all depends on how well mixed across the lake it gets, and that's not something that the current data has collected to tease that out. So all really good points, and we're making notes of them all. So yeah, keep them coming, folks, because we really like it.
And that is a really interesting option, and I think that would be, that's kind of a more distributed aeration process than a centralized aeration, and sometimes that can be more cost effective. But again, it has to be part of a comprehensive plan, and it has to be well thought out so that there's, just so folks aren't wasting their money putting something in that's not optimized for the situation. So I think it's a really good idea that this should be considered.
And it could be the opposite, meaning that it could be more effective to have a couple aerators in the middle of the lake at the deepest place where we have a higher likelihood of anoxic conditions. I don't know that. I'm just saying that that's the kind of thing we would want to consider.
Yeah,
Is
right.
what are the combination of strategies that would work? Because if you did put something out in the middle of the lake, then maybe it's worth creating a lake management district through the county or a nonprofit that allows you to seek funding as a group to put in those aerators in the middle of the lake. I'm just throwing out a theoretical here. There's a lot of other ways to do this.
Yeah.
And we're happy to spell those out. Some of those are spelled out in the draft report. Someone asked the question about, does the final report require an action done by the county or the community? No, that's the short answer. What the report is supposed to do at the end of the day is provide a lot of recommendations. And then it's really up to the community working with the county to figure out what's the best path forward. So at the end of the day, the plan may have recommendations on short-term strategies and long-term strategies and some of these funding sources and possible next steps and that kind of thing. But the report itself is not meant to give a super prescriptive, do this, do this, do this in this order, because really you as a community get to weigh in on that. You may not want a lake management district. You may decide you want a nonprofit. Fine, right? But at least we're laying out some options for you to weigh in on, and you can give feedback to the county on that. I hope that helps. And maybe before this process is done in the final report in May 31st, you folks will all have come to consensus that you think one idea is better than another for how you might move forward. And that's great. We just don't want to a priori prescribe that for you. We can give you lots of information. We just don't want to dictate it, if that makes sense.
And regarding the aerators, I mean, I remember hearing some stories about how it actually made situation worse if it's stirring up the sediment.
Yes.
Therefore, it depends on a lot of different things: the sediment type, how deep, how much, whether they're installed properly. Because if you're stirring up the sediment, you're releasing more phosphorus. So.
Yeah, please don't introduce carp to your lake. Please do not do that. Please, please, please do not do that. That is a huge problem. Carp tend to stir up the sediments, make it more turbid, make some of that sediments that were consolidated now fluff up and become available to be broken down in an anoxic condition. Ultrasonic. I have very little experience with that. I've heard of it. I'm aware of it. My understanding is it's still in the pilot phase. We haven't seen enough examples of it being used in lakes to know how effective it is. Certainly the folks that sell that equipment have done lots of tests, some probably limited. But again, it's sort of like what Elizabeth was saying with the aerators. There will be situations where the aerators work really well and others where they're going to like make the problem worse. And so ultrasonic sounds great, but it can also be quite expensive. Just like the aeration systems or treatments, they all have costs associated with them. And so there's a bit of a cost benefit to figure out, like, because the ultrasonic might break up the algal cells, but it's not going to do anything about reducing the nutrient loads. It's not going to do anything about the sources. You're just treating literally the bottom of the barrel symptom, which is the actual algae. It's just food for thought, not a criticism at all. But this is how you kind of weigh these different strategies and consider them. So,
Yeah. And another point on the carp is they do have a type of catfish. It's called the brown head bull, I think, fish, and it's a type of catfish that is already stirring up the sediments. It's just not as bad as carp. And over the 12 years I was at Ecology, when people would call or contact me about their lakes and talking about it, didn't used to be like this 30 years ago. One of my first comments was, do you have carp? And
exactly.
So many times, I would say 80% of the time, they did have carp, and so carp tend to be just cause so many problems.
Yeah.
All right.
Other questions, comments?
Comments? Yeah.
Well, again, we'll probably see many of you in person on April 1st. We'll still continue to have public comment in the month of April. So
thank you very much, everybody, for staying a little bit longer and thank you for your patience as we went through this. I hope it was really helpful for you, and we're looking forward to, actually, we're really looking forward to meeting you all in person. And I'll share this presentation with Anna, and then she can pass it on to you folks. And likewise with the draft document, you'll get a chance to weigh in on that as well.
Yeah, and
Anna?
Mark, at what point do you think we'll make the draft document available for public review?
I think we'll be, let's see, what is this? Maybe by like the first week of March or so.
Okay.
Should be good.
Sounds good. And I meant to mention this, or yeah, I was meaning to mention this in the beginning of the presentation. I know a lot of folks have signed off, but if anybody is not signed up for our listserv, we do send out notifications about this project. So if you want to be notified about any updates, please put your email in the chat and we'll add you to the listserv. And again, sorry that I forgot to mention that in the beginning. But yeah, we'll make all of these materials available soon, and we'll try to make this process as transparent as possible. We really value everybody's time and feedback. And yeah, big thanks to Mark and Rob and Lisbeth for taking the time to analyze all of this data and put it into a comprehensible format. So yeah, we really appreciate it.
Thank you very much, Anna.
Right.
Awesome. Thanks,
Right.
everyone. Have a great night.
All right.
Yep.
Thanks everyone.
Yep.
Bye now.
Take care.
Bye.
Have a great night.
Evening.